Let's solve this equation that has radicals in it. We'll follow our 5 steps. Step 1, isolate the radical. Well, it's isolated, but let's move it over to the left side. Step 2, raise both sides to the power of the index. Well, the index here is the invisible 2 in the hook, so we're going to raise both sides to this 2 power, the second power. It cancels the radical on the left. We get 2x minus 3 equals, now we have to square x minus 9 as x minus 9 times x minus 9. Let's go ahead and we're getting rid of the parentheses. What we do is we get rid of the parentheses on the right side by foiling. Now we're ready for step 4. Step 4 is to solve the equation that we have since we've gotten rid of the radicals. And you'll see here the highest power is the second power. So to solve a second degree equation, we move everything over to the left side. And the right side will be 0. And then we're going to factor the non-zero side. So we have x squared minus 20x plus 84 on the left side. It's going to factor as parenthesis x minus 6 times parenthesis x minus 14. Bring down the equal sign, bring down the 0. Solve this equation by setting each of the factors equal to 0. X minus 6 equals 0 or x minus 14 equals 0. And then solve for x. We get x equals 6 and x equals 14. Step 5 you cannot skip. We must check each of our solutions by plugging the value into the original equation and seeing if it makes both sides equal. So first we'll take the original equation, replace x with 6. We'll get 6 minus 9 and ask, is that equal to the square root of 2 times 6 minus 3? Well, that means that we're asking, is negative 3 equal to the square root of 9? Well, they introduced the square root sign. I didn't, so the answer is positive 3 on the right side. Negative 3 is not equal to 3, so no, that's a bad solution. Let's check the other, x equals 14. Plug it into both sides of the equation, put a question mark in between, simplify each side separately. We get 5. Is that equal to the square root of 28 minus 3? 5, is that equal to the square root of 25? Now remember, they introduced that square root symbol when they gave us the problem. I did not introduce it, so I don't have to consider both the positive and negative square root, only the positive square root. And so the positive square root of 25 is positive 5, so yes, 5 is equal to 5, which means we only have one good solution, the other one's bad. So cross out the bad one, keep the good one, x equals 14. Let's move on and do one more situation, solving an equation that has radicals in it. Now this problem's more complicated because there's more than one radical term. See the 2 radicals being added on the left side? That's fine. We just choose one to concentrate on and we'll apply the steps to that one. Let's concentrate on the leftmost radical. So step 1, isolate the radical on the left side. Okay, we'll get the square root of 2x plus 5 equals 5 minus the square root of x plus 2. So we move the other radical to the other side. Step 2, raise both sides to the power of the index. It's the invisible 2 in the hook, so we raise both sides to the power 2. Be very careful on the right side because you have 2 terms separated by that minus sign. In parentheses, raised to the second power. So you're not allowed to distribute the second power across addition or subtraction. You're going to have to take the base in the parenthesis, x minus the square root of x plus 2, and multiply it by itself. That's what it means to raise it to the second power. Simplifying to get rid of parentheses on the left, we get 2x plus 5. On the right, we set up our FOIL, 5 minus square root times 5 minus square root. Okay, bring down the 2x plus 5, bring down the equal sign, and FOIL, combining like terms in the middle, and you're going to get 25 minus 10 times the square root of x plus 2, and then at the end, you're going to square root, which actually cancels the radical sign. Bring everything down and simplify. You get 2x plus 5 equals 25 minus 10 square root of x plus 2 plus x plus 2. Okay, so here we are trying to get rid of our radicals, and we look at this thing and we go, hey, we still have a radical. What are we going to do now? We're going to have to take it where it's at now and return to step 1 to get rid of this other radical that won't go away. So taking this result and returning to step 1, we need to isolate the radical. So let's move 25 over to the other side by subtracting it from both sides. Let's get rid of the x plus 2 on the right by subtracting the x and subtracting the 2 from both sides. And then we're almost finished isolating our radical. The problem is there's a factor in front of our radicals. You'll see right here, x minus 22 equals negative 10 times the square root of x plus 2. So let's get rid of that negative 10. Let's divide both sides by negative 10. So that gives us x minus 22 on top of the fraction divided by a negative 10 equals the square root of x plus 2. Great, great. We've got the radical isolated. Let's turn it around and put it on the left side. Now we can move to step 2 where we raise both sides to the power of the index. So we're going to raise both sides to the second power. Now that's great on the left side. That's going to get rid of the radical. Now on the right side, it's a little bit more complicated because we have a fraction, but no problem. Remember, the rules say that if we have a power on a fraction, we can apply that power, that exponent, to the top and to the bottom. So we're going to apply the second power to the top and the second power to the bottom. On the left side, now we're getting rid of parentheses in step 3. We get rid of the radical by squaring the square root. But on the right side, we're applying the second power to the top. And again, we have to FOIL x minus 22 times itself. On the bottom, we have negative 10 times negative 10 when we square the entire bottom, and that gives us a positive 100. Now let's FOIL the numerator, the top of the fraction, and we'll bring down the x plus 2, bring down the equal sign, FOIL the top of the fraction, and combine like terms, you'll get x squared minus 44x plus 484. Divide that by 100. Now, we're trying to solve this equation. It's second degree, but first of all, it's an equation that has fractions. Let's get rid of the fractions by multiplying both sides by the LCD. The LCD is 100. And that gives us 100 times the left side, parenthesis, x plus 2 equals, we'll just cancel the 100 on the right side, and you no longer have a fraction. Distribute the 100 on the left side, you'll get 100x plus 200 equals x squared minus 44x plus 484. Okay, second degree equation. We want to get everything on the left side and the right side to be 0. So first we turn it backwards, and then we move everything over so we have 0 on the right side. And then we're going to get rid of the, we're going to factor the left side, of course. We guess, and we get x minus 2 times x minus 142. Set each of your factors equal to 0 and solve, and you get these two solutions. If you check the right solution, it's bad, so you have to throw it away. The other one is good, and we can just keep the one good solution, x equals 2.